So this video is going to walk you through just an introduction of proofs, two-column proofs, and then we'll probably get to two examples of actual proofs that we'll do start to finish. So first thing is there are different ways to do a proof in geometry. You could do a paragraph proof, which would be when you are writing your proof statements in sentences. There's also like a flow chart, which would be more of like a diagram. But the most popular is going to be what is known as the two-column proof. All right, so that's what we are going to work on. So a two-column proof. All right, now, proof. Sorry about that. Pretend like that doesn't look like whatever. Anyhow, okay, so two-column proof implies that we have two columns, which we do. So first column is what is labeled as the statements. So statements. And then the right column is the reasons. So what's happening here is that we're going to be given two triangles like we've been practicing, and you will need to determine if the triangles are congruent, and if so, how they are congruent. And by that I mean side, angle, side, side, angle, side, 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 maybe hypotenuse, leg. So you're going to determine how the triangles are congruent. And then what you're going to do is write each statement out. So if it's side, 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 you're going to show that the first two sides are congruent, then the next two, then the next two. And under the reasons, you're going to put how you know that. So what we also do whenever we write a two-column proof is we number the lines so that even if our writing gets a little off a little bit, or we have to extend a line, we can see which one matches up with what. So we always number them. So this statement matches with that reason. This statement matches up with that reason. This statement matches up with this reason. Now, for what we are doing, most of our proofs are going to end up being 4 statements in length. All right. And you can have a proof with 15 statements. But the ones that we're doing, we really should be able to get them done in 4. All right. Now, what's going to happen is the first 3 lines are going to be the parts of the triangle. So maybe we have side, angle, side. So what would happen would be this one would be proving that the sides were congruent. This one would prove the angles are congruent, and that one would show that the sides are congruent. All right, now our reasons for those things can be anything from, oops, I picked up the wrong color, can be anything from, it could be information that was given to us. It could be something like we know from Math 8 that vertical angles are congruent. We know from Math 8 that alternate interior angles are congruent. Let's see, we also learned this year what reflexive property is. So anytime we are using the same part of a triangle in both triangles, it's still going to be congruent. So an angle is always going to be congruent to itself if it's used in both triangles. So that's our reflexive property, but we'll get to that in just a few minutes. And then what's going to happen is your 4th statement is where you're going to say triangle blah, blah, blah is congruent to triangle blah, blah, blah. And your reason is going to be your 3 letters that you prove. So if we were doing this one, this would say side, angle, side. And again, that's just an example. All right, so that's the basic setup. So these are some non-negotiables. This is titled statements. This is reasons. You should be numbering your statements as and reasons as you go so you can see how they're matching up. All right, so in the interest of time and length of video, I pre-wrote out the first example. So if you need to pause the video so you can get this written down, then please do so. And then once you have yours drawn out, then you can go ahead and continue the video. So on this one, this would be what you're given. So this would be an example of a problem you're given. So you have a picture over here, you have given information, and then you're shown which triangles you're supposed to prove are congruent. Now this one's pretty obvious because although there are 3 triangles in this picture right here, we're obviously trying to prove that these 2 are congruent to each other. But sometimes a picture can be more complicated, so you want to make sure you're paying attention to the 2 triangles that you're trying to prove. So in this example, we are trying to prove that this triangle right here, which is SRT, so this triangle right here, we're trying to show is congruent to this triangle right there. Okay? Now, we have marked on the picture, which is just a guide. It's not necessarily drawn to scale, but we have marked on the picture that those 2 sides are congruent. But then in the written given information, we're told that ST is congruent to QT. So I'm going to mark that one on my picture as well. So ST, which is this piece, is congruent to QT, which is that piece. And let's use 2 marks so we don't get that confused. So right now, this is what I'm given. So what we previously did was to look at a picture like this, and then we would think about, well, what else or how else could we prove that these triangles are congruent? We don't know anything about any of the angles. It may appear that those are right angles, but we don't know that. So what we would need to remind ourselves is that RT is a part of that triangle and it's a part of that one, and RT isn't going to change its size. So the fact that that piece is used in both triangles would tell me that it's going to be congruent to itself. And that is what the reflexive property can do for us. So now we can prove that these triangles are congruent by side, side, side. All right, that's what we previously did. Now what we're going to do is actually write out the proof for it. So left side is statements. Right column is reasons. Now, we are going to shorten our reasons just a little bit, but we don't want to, overdo it because you are trying to write out a geometric proof. So we are going to abbreviate a little bit, but we can't skip information. Okay, so first thing we're going to do is put our given information. So right here we were given that ST is congruent to QT. So that the reason is that was just given information. So that was told to us at the top in the statement. All right, now right here in the picture, it was marked that RS is congruent to RQ. So that's also given information. So RS is congruent to RQ. So those 2 segments are congruent, and that is also given information. All right, now we determined that RT was congruent to itself. So RT is congruent to RT. And anytime we are showing that something is congruent to itself, that's always reflexive property. So reflexive property is the reason. Now we don't need to explain reflexive property because that, by putting the reason, that implies that we understand that reflexive property is when a segment is congruent to itself, or could even be an angle. So now we have our first corresponding sides right here. This is our second set right there. This is our third set right here. So now what we can say is, and I'm going to rewrite this statement right here, SRT is congruent to triangle QRT, and the reason is side, side, side. So we are going to abbreviate. We don't want to overdo it. All right, so there's your first proof. So you have your 3 parts of corresponding congruent pieces, and then the last one is going to just say the reason, which is the side, side, side. All right, I have example 2 drawn out here as well, and again, if you'll just pause the video so that you can get it written out. All right, so for this example, we are given that MN is congruent to PO. So MN is congruent to PO. So I'm going to mark that on the triangle. I can also tell by looking at the sketch that these are right triangles, which tells me that if I can prove that the hypotenuse and leg are congruent, then that would be the 3 things. It's a right triangle, and then we have a hypotenuse and a leg. Well, we can see right here that ON and NO are in both pieces of the triangle. So that would mean that it's going to be reflexive property right there. All right, so looks like we're going to use hypotenuse leg. So statements and reasons. And I understand that this is, a little tiresome here, but this is what it is. All right, so we have 1, 2, 3, 4, 1, 2, 3, 4, and I know that my reason over here is going to be hypotenuse leg. So now I have to prove that. Okay, so first thing, we were given that segment MN is congruent to segment PO. And the reason is that was given. Okay, so that was our given statement right here. That's the one marked right there. All right, we were also given in the picture that these are right triangles. So I'm going to say triangle MON and triangle PNO are right triangles. Sorry, I didn't leave enough space down here. All right, now that was also given. Now, this is a requirement. In order to use HL, you have to show that those triangles are right triangles. So we were given the right angle mark, so we can tell looking at that that's a right triangle and that one's a right triangle. All right, our next statement is we identified that ON and NO were used in both sets of triangles. So ON and NO are congruent. So NO is congruent to ON, those 2 segments, and that is reflexive property. Oops, running out of space. So now we've done our 3 things. We have this right here was our hypotenuse. This told us that it was a right triangle. And then this is our leg. So we have proven hypotenuse leg. So now our statement is that triangle MON is congruent to triangle PNO. And the reason is hypotenuse leg. All right, so that gives you a little introduction. Again, I understand that there is a lot of writing in this, but welcome to Proofs in Geometry.